Hello everyone and welcome back to my YouTube channel. I'm Mayank Agarwal and in the day 14 of our Hello Python series, today we are going to learn about membership and binary operators. So let's get started. Okay everyone, so let us begin with membership operator first. So membership operator is actually used to test whether a value or a variable is found in a sequence. Okay, so whenever let's say we are dealing with things like list, we are going to study about these, but let's say whenever things are kept all together, right? So membership operator is pretty intuitive to understand as well. Like let's say you have different fruits present, right? Let's say there is an apple, okay, then there is let's say an orange, and let's say there is basically a banana. Now in this particularly, this is what I'm calling as a sequence. Now in this, if I ask you if banana is in this sequence, then you're gonna say yes. But if I ask you if watermelon is there, then your answer is gonna be no. So the same thing, okay, the same thing in Python is actually achieved by membership operator. So membership operator is used to test whether a value or a variable is found in a sequence. Okay, sequence can be string, list, tuple, set, etc. Okay, so there are two major membership operators and like two only actually, in and not in. I think it's pretty intuitive, but let's understand about them. In operator is used to check if a value exists in a sequence or not. Okay, it returns true if it is present. If it is not, it returns false. Not in, on the other hand, okay, it actually returns true when the value is not present. Okay, so I hope this is pretty much clear to understand that whenever value is not present. So if I would have asked if watermelon not in that sequence, then you would have given the true as an answer, right? So that is what your membership operator overall do. Now again, make sure that you understand them because they are used to I would say write logic. So we are going to study about decision control statement, basically if and not if, and that is majorly where these things are used. Now in the industry setting, let's say if you are trying to basically write some logic, right? Let's say you have to send some something to people who have Gmail ID or who have a ID from your company. Now you can get that ID and you can check if let's say Gmail is present in that ID, and then you're going to do your logic, right? So in a similar way, we have to basically make sure that we are able to find what all is present and then work on that part of code. So let us see some examples. Let's say if A is Mayank. Okay, I'm first checking if AYA is present in Mayank. So AYA. And I think you can see that AYA is present here, right? So the answer is going to be true. Now the next one is MAY. But you have to make sure that you understand one thing here, okay? A very smart thing, that M is small here, whereas mine one has a capital M. So it is case sensitive, okay? So it's going to return the answer as false. Let me show you that quickly so that you understand this. 1 second. Yeah. So let's say if my S is equals to Mayank, right? Then if I write A by A in S, it's true. But if I write, okay, let me make it capital M. Okay, if I write MAY in S, it's false. And the reason, I think now you understand that it's case sensitive. Okay, so that you have to understand always. Now, in the next thing is 2 in 2, 3, 5, 7. So we know this answer. Okay, so I think you know the answer. It's going to be true. Okay, and similarly 11 not in 1, 12, 3, that's also going to be true because 11 is not there. Let me show you this one. So the overall this sequence with the brackets, okay, square bracket is a list. So what we can do is we can create a list. Let's say L1. We are going to of course understand about everything all together, so it should be fine. So our question was 11 not in L1. So it's the same, like watermelon was not in that particular sequence of fruits. Similarly here also it is true. Okay. One thing what I would like to check. So let's say if I'm defining my A here as let's say Mayank 1, 2, 3 Python, something like that. Okay. So let's say if I check 1 in A, okay. So it's giving an answer in string requires an left operand, not int. So it is basically saying that, hey, you are trying to find an integer in a string. But we know that integers cannot be found in a string, right? You have to give a character or a string only. So that is what this error says. And you have to make sure that you write like this. And now it's true. Okay. So I hope this is clear. One more thing to note and always remember is that this is not going to work in, I would say, on a normal number. So let's say if you have 1, 2, 3, like, because this is not a sequence or an iterable where things are stored. Okay. So you cannot ask if let's say orange is an apple because apple is a single unit. Similarly, this 1, 3, 2, 4, it's a single unit. So if you say 1, 3 in B, it's an error because argument type int is not iterable. Okay, you cannot iterate over it. Like you cannot pick things one by one. So when I say sequence, I mean iterable here as well. Iterable is nothing, just that you are picking them one by one. I will make the difference clear in the future. Right now, you can just think of sequence because that is easy to understand. Okay, so these are your membership operators. They are used a lot, especially when writing the logic. Okay, so you have to make sure that you understand them properly. Okay, where they can give the error, where they cannot give an error. I've seen students make a mistake like this, so I'd want to make sure that you don't do that in industry, or let's say whenever you are creating any other application for yourself as well. Okay, so now let us move to the binary or bitwise operators. Now they are used actually a lot, I would say, in problem solving, because they are like the basic way that I would say things are saved. Okay, so let us understand about them as well. Now a bit, okay, bit is actually the most basic unit of information. Like actually when the computer started, right, it was just that we're able to switch off something or switch on something, and that used to mean something. Okay, now bit can be a 0 or 1. Second, yeah, bit can be 0 or 1, and bitwise operator works on the bit, I would say basically on the bits. So you can think intuitively of bits as, like, let's say we have a language, right? We are communicating in English, or या फिर हम हिंदी में we can हम बात कर सकते हैं. तो let's say if tomorrow some language is there, and actually that is what happens in computer, कि everything is just stored as a value of 0 or 1. ठीक है, तो आप let's say for hello I would have something as 0 and 1. Okay, and that's where it's gonna work. Okay, so integers have to be represented into binary form and then operation done on them. Okay, so you have to always make sure that you understand that, and I'm going to show you exactly that how we do that, so that if anyone is new as well, he doesn't face any issue. And they are also used like majorly in the code or software development, but they are used as well. Now again I can show you that exactly. Let's say this is a string to binary website. So if I've written hello Python, okay, see, this is the encoded string in bits. So everything can actually be written as 0 or 1. You can just think of if tomorrow some language is there, right, जिसमें only 0 and 1 is present, or 2 words are there. Okay, so different things can basically be I would say represented as of the part of those 2 words. Okay, so that is what we have to do. Now let us understand a little bit more, I would say, about these bits and how to work on them. So the very first thing which you have to understand is integer to binary representation. Now let's say if you are given an integer, how are you going to make binary representation? How are you going to give that binary representation of it? So you have to understand one thing, that basically binary always means 2, right? So you must have done this in school, college, everything, but I must still make you revise this. We basically write it like this: 1, 2, 4. These are the power of your 2. Okay, so it is 2 to the power 0 here. Let me write this as well. So it is going to be 2 to the power 0 here, 2 to the power 1. This is actually 2 to the power 2, and this is 2 to the power 3. Now based on what value I have, for example in 5, I want a 4 and I want a 1. So that is why 1, 0, 1, because here I don't want it. If this would have also be 1, then I would have gotten 7. Okay, so you add these things, 4 plus 1. That is what you get as 5. Now this we are making as, we write as 2 basically normally in, I would say, textbook and everything, you might find it written, because we have hexadecimal and other representation as well, though we are working on binary only. Similarly, 4 can actually be represented like this. So 1, 0, 0 and 2. And all the other left bits are actually going to be 0. So it doesn't matter, like of course they are 0, 0 only. Okay, so that is how we do the binary representation. Now for the timing, we can actually also write the same as 6 as well. So let's say if it is 6, okay. So the way we are going to do it is 6 is going to be like this: 1, 1 and 0, right? And everything else is going to be 0 only. So that is how you're going to write 6. Now I hope this is clear as well. We want a 2, we want a 4. 4 plus 2 is 6. So that is what my binary representation is. Now any binary operator, in memory, they basically convert your, I would say, number into this and then work on the same. So that thing again is very important to understand, that how they work on this. So let us see what different binary or bitwise operators you have. So we majorly have these 6 bitwise operators, and we are going to learn about them one by one very nicely with the example as well as using in code. If you're liking everything, basically the way I'm teaching, especially the Hello Python series, and I can assure you this is going to make your base in Python a lot strong, please make sure that you like this video, subscribe to my channel and share this with your friends. Okay, and also hit that bell icon so you never miss any video on this series as well as other series and others, I would say, videos which I'm going to make on my channel. So there are 6 major operators. Okay, ampersand, bitwise, and, or. This is XOR, right? Bitwise XOR, and I'm going to cover them properly in the next slide. So basically this is your overall, I would say, complement, then right shift and left shift. Okay, so and you have an assignment as well. So if you remember, right, so I'm giving, still basically providing you each and everything with your lectures as well. So here you're going to see that the full thing is basically covered very nicely. So please make sure that you download that. These notes I believe will be a lot helpful along with my handwritten notes. Like these are also the handwritten which I have created after a lot of effort. So that, because I personally feel that it is a lot useful in revising things, right? Maybe it is because like before your exams, before your placements, internships, or even I would say whenever you're giving any other interview. Okay, so everything is basically explained, but we are going to still make sure, okay, that we understand them completely from scratch. So now bitwise, let us do them one by one. So the very first is bitwise AND. Okay, here you have to understand this truth table and basically this overall circuit. Now, pretty sure that you must have seen this in your a school textbook as well, right? So and basically works on the logic that if anything is 0, okay, it basically said as a multiplication as well, because 0 into 0 is 0, okay, 0 into 1 0, 1 into 0 0, and just 1 into 1 is basically your 1. So in a similar way your AND works and gives the result. So let's say if we are doing 5 and 4, okay, so see what's going to happen. This is the representation of 5, this is the representation of 4, and this is on what your overall, I would say, bitwise operator is going to work on, this AND operator. So 1 and 0 is 0. Similarly, 0 and 0 is 0, and 1 and 1 is going to be 1. And that is what you will get the answer. Your answer is going to be 4. And you have this truth table as well in this note. So please make sure that you are able to work on few of them. I will give you questions as well. So let us see this once. Yeah. So let us have this binary. Now let's say if I have A is equals to 5 and say B is equals to 4. And if I do A and B, so see the answer is 4. And see, the thing is you have to understand that why answer is coming as 4, right? Because some interviewer or normally you can see that, and many students are not aware that how it's happening. So I want to make sure that you understand these things. Okay, so please make sure that you practice on like the question which I am giving, as well as a lot on practice on this, because these are the basics. They are going to be helpful in any, I would say, career which you're going to make in coding. Okay. Similarly, we have the next one, which is bitwise OR. Now bitwise OR is normally set as plus. So 0 0 is just 0. Rest everything is 1. So 0 plus 1, 1. 1 plus 0, 1. And 1 plus 1 is also 1. Okay. So please make sure that you understand that always. Now, if in this you're going to see this 1 0. Okay. 1 second. Yeah. 1 0 is 1. 0 0 is 0. And 1 1 is going to be 1. And basically this is what we're going to tell what our answer is going to be. And answer is going to be 5. So let us try that as well. 1 second. Yeah. So this is the symbol of OR. It's above your enter. And you're getting the answer as 5. Okay, so always remember this table, and you're gonna, like, if you will see my notes, okay, these handwritten notes, you will be actually at a very good place, because I have make sure that you don't have to go anywhere from there. Okay, so let us similarly move to XOR. Now XOR, the logic is basically like, let's say if they are same, then it's gonna be 0. If they are different, then it's gonna be 1. Okay, so different basically cause the bulb to get on. So 0 0 is 0. Similarly 1 1 is 0, and then 0 1 is 1, and 1 0 is 1. Okay, so this is the logic overall, the result you get. The Q here is actually the result. Now in a similar way, we have 5 and 4. Okay, so 1 0 is going to be 1, 0 0 is going to be 0, and 1 1 is going to be 0. That's what like the logic says, and that is how it's going to get, I would say, that is how you're going to get the answer. So let us quickly check the same as well. Now taking the same example, so we are able to check it as well. It's on 6, this icon, and you're getting the 1 as an answer. Okay. So this is what bitwise OR is. Now we have covered 3 of them. I hope you're liking it. If you're liking, please make sure that you also leave the comment, so I know that, okay, you're liking the way I'm teaching, basically using these notes and everything, because of course it's take a lot of effort, right? And you will be getting these notes as well. So please make sure that you use it to the fullest. Now the next one is left shift. So left shift, as the name suggests, you are just shifting to the left. Okay. So let us take the example. We shift the bits to the left. Okay. In a real sense, if you will also understand this, it is actually just, I would say, moving by 2, right? So sorry, multiplying by 2. If you think on this, like, see, we write this 1, 2, 4, 8 and everything like this. So when you left shift something, you are just multiplying that by 2. And we will see the same as well. See, this is your 5. Okay. Now we have this representation as 1 0 1. Now when I'm left shifting it by 1 point, so it takes actually an integer here, like how much you want to left shift. You will be moving it like this, all the bits. And this 0 basically, if it shows present here, it's going to come like this. You can imagine that it's going to come to your 1th position, this position, and everything else is going to move like this. So now it's 8 plus 2, which is 10. And if you will actually see, 5 into 2 is 10, right? So if I write it here, 5, 1, it's 10. I hope you now understand that why 5, 2 is going to be 20. Because again, we are going to make them shift. We are going to make him shift 1 by 1. Okay, we are going to shift them 1 by 1. And in a way that is getting multiplied by 2. So you can remember the answer easily as well in this. Just that whenever we do left shift, we are multiplying by 2. And now you know the logic as well. That's exactly how it's happening. Okay, so I hope left shift is also clear. The next one is your right shift. Again, the thing is same, but here you have to understand one thing, that our bits can also get lost. Because when we are shifting to the right, we don't have anything after this, right? We don't have anything after this. So it is not actually getting, I would say, some decimal or something. No, nothing like that is happening. Okay, and in a way that is dividing by 2 as well. Like if you can, like if left shift was multiplying by 2, then right shift is dividing by 2. Okay, so see here 5. Then if let's say I'm shifting it, then this bit is going to get lost. That is something which you have always want you to remember, that Here we can lose some information as well, and this bit is lost, right? So please make sure that you understand this. Now, if you have any doubts, please ask the same in the chat as well, sorry, in the comment as well, and I'm going to make sure that I clear them. Similarly, if you do it 2 times, then this bit is also going to get lost. And in a way, like 5 divided by 2 is equal to 2, like the quotient is 2, that is what you're getting, then 2 divided by 2 is 1. So the understanding is same, we just shift the bits to the right. Okay, bit can get lost if 1 is on the right side. Like 0 we normally don't care about, right? We say that 0, okay, no bit is there, but on 1 the bit is, or the bulb is open and the bit is present there. So that is where we say that bit can get lost here, and in this example it is getting lost as well. So if I just do this, 5, 1, the answer is 2. Then let's say if I do 5, 2, the answer is 1. Easy way to remember this, if I do this, it's just dividing by 2, so answer is going to be 5. Okay, so I hope each and everything till now is clear. These are the most, I would say, best way to teach about this, just by seeing the binary representation and then seeing the operation on Python directly. Now the next one is actually the complement. Okay, now this is actually a little different. This is a little different than the other ones. Like other ones was directly working on bits. It also works on bits, but there is some different thing, basically majorly on how the negative numbers are stored. Because till now, if you will pay attention, we were just dealing with positive numbers. Like there is no way we can actually store negative numbers into our, I would say, system if we follow this bit system, because everything is positive here. What happens in the background is that actually most programming language, I think they work on the 2's complement. Like they store the 2's complement of a number as a negative number if they have to store a negative number. Like we have to make sure that some bit we are keeping as a sign bit, where let's say we say ki, if this is 1, then it's a negative sign. If this is not 1, then it's a positive sign. Okay, so we're going to understand each and everything here, but I just want you to make sure that you understand this thing, that why exactly this is different. Okay, so as I written here, the logic is a little different due to the way negative numbers are stored. Okay, bit on the left side is basically used. Now if we do 5, and complement is just basically switching, like 0 to 1, 1 to 0. That is what complement is. So if you have a, like it was actually a not operator, honestly. Okay, so if you have 5, you're going to change it to 0, 1, 0, 1, like this. Sorry, this is your 5 representation. We are just going to split it. Okay, so this should have become 0. My bad, I have written it wrongly. Yeah, we're just going to return it. I've made a mistake here, so just correcting that. So now it's become actually 10. 1 second. Yeah, so basically the answer was same, but just time is that bit. Anyways, so this is going to be 10 if we make it like this, but 10 is not the answer. Now I want you to understand one more thing, that we actually took this 0. If we would not have taken, then we would have said the answer is 2. But I think again that is wrong as well, right? So that is also not the answer. So we have to understand how exactly this happens, and the answer is going to be negative here. Because see, if you would have this 0 as well, then you would have make it 1, and then you would have said, yeah, we can, it is basically 16 plus 8 plus 2. But that is not how it happens. Okay, so above is not 10, as we would have all ones. Okay, on the thirds, basically along the third bit also, here everything is going to be 1 as well, right? If we extend it. So that is not how it happens. Now you have to understand the concept of 1's and the 2's complement here. So 1's complement is just flipping the bits. So that's just the complement which you take. 2's complement is that when we add 1 to the 1's complement. Okay, so whenever we have a 1's complement and we are adding 1 to that, that is what 2's complement is. Now in machine, negative number, as I've written, is stored as a 2's complement, right? So for example, this bit of 5, okay, we have made it 1 0 1 1. Okay, we have made it 1 0 1 1. Now normally we say that through this is something where we are, I would say, identifying it as a negative number, but overall the way it happens is like it is still not going to be negative 3, like it is not negative 3 again, because 1's complement is not saved. This is just, you have made a complement once, right? So I will repeat myself. 2's complement is saved in machine as a negative number. When we just complemented 5, the binary representation of 5, it is still 1's complement. We have complemented it once. Now we have to add 1 to that as well. Okay, so above is a negative number, but not minus 3, as 2's complement is stored. This is also where many students get confused. So you have to make sure that you understand this. And that is the reason I've made sure that I've written everything in the notes. Now the next thing is, so what we want to do. So see, now the full step process is written. We have to take the result. Okay, so 1 0 1 1 was the result, right? We take the 1's complement. We take the 1 complement. So it is going to be 0 1 0 1. Okay, and then we add 1 to this basically number to get the 2's complement. So first you take the result which you get after complementing the number. Okay, you are again complementing it, and then you add 1 to this particular number Okay, you add 1 to this particular number to get the result. Now, if you pay attention here, this is actually how the addition is done. So 1 plus 1 is actually 10. 0 plus 1 and 1, 0 plus 0 and 0 plus 1, 1 plus 0 and 0 plus 0 are fine, right? 1 plus 0 is going to be 1. Similarly, 0 plus 1 is going to be 1. 0 plus 0 is going to be 0 again. But when it is 1 plus 1 and when you are adding it, it basically have a carryover, okay, which is 10. So you write 0 and you carry over 1. So that is what I've done here. If you will see, add 1 to get 2's complement. Okay, so 0, 1, 0, 1. Now we add 1 here. Now 1 and 1 is 10. So I write 0 here and I carry over 1. Now this 1 and 0, okay, normally the way you used to do maths, 1 and 0 is going to be 1. So I written 1 here. Now here you can just actually assume all 0. So 1 and 0 is going to be 1 and this 0. And this is actually your value. So if you will see, now this is 6 and minus 6 is going to be the answer. So 6 is actually present here and answer is going to be minus 6. Because overall our sign got flipped, right? So let us see this once in the code as well, everyone. So let us take, let's say C is equals to 5. And if I just do this C, I'm getting minus 6 as an answer. I'm getting minus 6 as an answer. Okay, so let us take one more example, I would say. So 0, 4 is going to be 1, 0, 0. Okay, 4 is going to be 1, 0, 0. Now first I have to take complement of 4. So I'm writing complement of 4. Like that's the total thing which I have to give. So it's going to be 0, 1, 1, right? Then, so let's follow the step. Take the result. This is the result which I got after complementing. Take 1's complement. So again, I have to take the complement. Okay. Complement 4 again. So I'm going to get 1, 0, 0. Now I have to make sure that I'm adding 1. So I'm doing so to another example. Adding plus 1 to the result. Okay. So 1, 0, 0. If I do just 1, 0, 0. Plus I am, let's say, adding 1 here, right? So the answer is going to be 1, 0, 1, right? So if we add just 1 here, now the answer is going to be 1, 0, 1. See here, it's going to be 1, 0, 1, right? So 1, 0, 1 is actually your basically 5, right? So 1, 0 is 1 is 5. Now in a similar way, if I take this bit of 4, it's coming out to be minus 5. Because if you will see this 1, 0, 1, we have already seen that is 5 only, right? Now, of course, this process might seem long, but you have to understand one thing and you will see something. The C, we are taking complements 2 times. So from where we started, we are actually reaching there only, right? So it is, I would say, very important to understand this process. Like now I'm telling you the shortcut to get the answer directly. Okay. So we have reached there only and we actually just added 1, right? So see, the simple answer is take the number, whatever you have given, okay, write it binary form, add 1 to it, and the result is basically whatever you get into minus 6. And that is what we have actually gotten here as well. Now, see, we started with 4. We have complemented it twice. So we got the original number. When we add 1 to it, and you have to understand how we add this thing. Whatever result you have gotten, so in this case, this was 5. Now from this, because this is 5, we are just gonna multiply it by minus 1. And here you got your result. Okay, so let us see this on one more thing. One more, because I think this is an important concept. So let's say 7 can actually be written as 1, 1, 1. Right, 7 is actually 1, 1, 1 if you will think, 4, 2, 1, right? So in a similar way, if I take, I can just add 1 to it, so it's going to be 1, 1, 1, and maybe I can take 0 here. Okay, let me actually do this on the notebook. That would be helpful to you to remember. So let's say, okay, let's say I have 7, which is equals to 1, 1, 1. I will just add 1 to 7. So 1, 1, 1 plus your 1. Now if you see this is going to be 0, 1. This again going to be 0, 1. This again going to be 0, and I will have 1 here, and I can of course take 0 like this. And this is the answer I'm getting. This is the answer I'm getting. So 1, 0, 0, it is going to actually 16 if you remember, see this. Like it is 2 to the power 4 here. So 1, 2, oh no, sorry, it is 8 actually, my bad. It is 8. Okay, it's not the 5th bit. So 8. Now the answer is minus 8. And let us see if our logic works. Okay, so just have extra this and the answer is minus 8. Okay, so I have made sure that give you enough examples and not hurry on this. I hope that is clear as well. Now what you can also do is I have given the full explanation, okay, everything with respect to anywhere you can get asked that, industry use cases, then questions as well as answers. Okay, so cool. So I hope this is actually a lot helpful in understanding I would say overall about your membership and binary operators. Again, these are used a lot. Binary operators especially are used a lot in software development and hardware plus everywhere. So you have to understand the basics and especially this not operator, because that I feel many students face the problem. And I've actually just created the notes and made sure that I give you enough examples. Okay, so with that we complete all the operators. Now in the next video we are going to learn some properties about operators. I hope you are able to actually learn and grasp everything. If you have any doubts, anything, please add them in the comments and I will answer that. Till then, we are going to meet in the next video. Okay, please make sure that you like the video and share it with your friends, and do subscribe to my channel. Thank you.